Hey everyone, today I'll be solving the problem of the day in Geeks for Geeks. I'll be showing you my thought process and how I approach a problem, and finally solution and code it for you so that you can also learn, practice, and grow. So let's just dive into the problem. So today's problem is smallest window containing all characters. It's a hard difficulty problem. Let's just read the problem statement. Problem statement is given two strings S and P. Find the smallest substring in S consisting of all the characters, including duplicates, okay, of the string P. Mm, okay. Return empty string in case of no substring, if no such substring is present, makes sense. If there are multiple such substring of the same length found, return the one with the least starting index. Okay. So basically, we have to return the smallest substring in S that has all the characters of string P. Okay, but does the order matter here? Wait, I'm not sure. Let's just go through the examples. First example is S is time to practice and T and P is TOC, and we get the output TOPRAC. Okay, so TOPRAC has TOC in order. So let's just go to the second example. Zoom, Laza, so something. P is OZA, and we get the output as APZO, where they are not in order. So I don't think order matters here. Okay, right. So in third में S is Zoom and P is Zoe something. So no substring found, which has all the characters of P. Got it. Let's see the constraints. S and P both have a maximum length of 10 power 6. Both consist of lowercase English letter. Got it. So let's just go through the example one by one to get a better understanding. S is time to practice, and P here is TOC, right? So what was the answer we got here? TOPRAC. TOPRAC, this one, right? And this is the smallest substring that has all the characters of P. Make sense? Let's go through the second one. Zoom. What was the Zoom Laza? So okay. Zoom Laza. So and P was OZO if I'm not wrong. OZA. Okay. OZA. So we got APZO, right? APZO. Where is APZO? APZO is at the end, and that is the smallest. And third is though we have Zoom here, we have Zoe here, so no substring. Got it. So I think this is like a pretty standard sliding window problem, wherein if we take the first example itself, I'll just erase this uh, second and third because that was straightforward. If we take the first example itself, I can start a window at the very beginning and start taking in all the characters until and unless I get every character which is there in P at least once. So till here I get C at least one times, T two times, and O also one time, right? And since we need the smallest substring, as soon as I get all the characters in S, I can then start uh, decreasing my window size from the left. So S equal to Ti. So I can then just decrease it from T because I already have a 2T, so I can remove 1T. I can remove, what's happening? I can remove I as well because I don't need the I because it's not in the P string. I can remove M, I can remove E, and then I cannot remove T again. So my window will stop here and I can take a note of it somewhere key by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can make a note key 5 to 10. There is a substring at 5 to 10, which I'm not sure. It might be the smallest, it might not be the smallest. I can just store its range somewhere and then again increase my window to find more such substrings. And I think ideally that should solve it. This is more of an implementation heavy problem where I have to maintain this I and J window size accordingly. And as soon as I get a window that get a smallest window that satisfies the condition where every character in P should be here, I can just make a note of ij and store it somewhere. And finally, we can return the minimum length of all these substrings. And if we have more than one minimum length, then we can return the minimum index from it, right? For example, if we have 5, 10, and if we have 6, 11, both has the same length, so we'll return this guy over here. Not exactly 5, 10, but the substring of 5, 10. Okay, let me jump to my laptop and we'll code this solution. So I am in my laptop now. So let's code out the solution. Um, so how I'm planning to approach this implementation was that I was planning to have a ij pointer of the window edges and keep I at the very beginning. Let's say I will be at 0 and then J would potentially be at -1 because I haven't started my window. Uh, I haven't taken any element at the window. So if I is at 0 and J is at 0, so my 0th element is in the window. If my I is at 0 and J is at 1, so both 0 and 1 is in the window, right? So yeah, so initially I would be at 0 and J would be -1 as I decided. Now, mm, okay, I also let's just take all the uh, characters from P and put it in a map, right? Let's just maintain two maps. What I'm thinking is we'll maintain a map, a hash map or a map for S and hash map for P. So P will be constant, right? And at any given point of time, at any given window of ij, if I want to check whether map S has all the element, not map S, whether the window, the characters in the window have all the elements from string P, I can simply use this map to just iterate over them and check such that map S has all the elements of map P. So that it becomes much convenient for me to every time do a check on the counts. Let me create a function for that so you'll understand what I'm trying to say. Anytime I want to check whether window satisfy constraint, I will pass in the map as unordered map. This will be of character and account. Let's call it S and unordered map of P, right? And to call it this name would be a bit too overhead or overcomplicating, but I think it's fine. So here, what I need to do is I need to check if all elements of S is there in P as well. So let's just iterate over uh, S, right? And if I dot first, which is the character, um, not the character, the count of that character. So if I dot second is less than P of I dot first, then I know it some element is not there in the map P. So I can just return false from here. And if all the elements satisfies this constraint, such that every element of S is equal to or greater than whatever I have in P, then I can just return true, right? And let's create these maps here as well. Not S and P, we can name it MS and MP, right? Unordered, unordered map, unordered map, my bad, right? Now let's just, since P is static, we can quickly iterate over it and put the elements there, right? This is basically frequency of each character. So at any given point of time, there will be 26, no more than 26 characters in either of the maps. And this will take like a max of worst case scenario O of 26, which is like a constant time. So we can assume it's O of 1. So this check is in O of 1, this particular check, right? Now, this is our window configuration where currently there is nothing in the window. Um, I can set a while condition कि my extreme end of the window, the right end of the window, should be within the length of my S string because that's where we are going to iterate, right? Now, uh, we can include we can increase J as soon as we enter the loop. We can include whatever point, like we can increase j and include that element at j to our window. So what I mean include the ms of s of j plus plus. We took this element and maintained it in our map, basically the S map. Right now, um, after this, after inserting the element, I need to check the window, does my window satisfies the constraint or not. Okay, so I'll pass ms and mp here, and if this guy returns true, then I know that my window satisfies the constraint and I can start shrinking it from the left. So let's do that. What I'll do is I will discard the ith, which is at 0, character or element from the ms map. So I'll say ms of um s of I minus minus, and I will increment I because I don't want, because I have, since I have discarded that ith element, I can move my I to the next element, right? And I have to do this unless and until this condition returns false. So I can just put this in a while and also add a safety check. He, my I should be less than j, then only, or less than equal to, because it can be possible that my I exceeded j just one time, as it was in the initial case where the window was empty. So I'm allowing my window to be empty here as well, right? Now after this while condition, uh, I know for sure कि either, so this didn't even execute once, right? I'm just trying to think. This didn't even execute once, and I just included something in my J, in my window via J. Uh, okay. Okay, and I think we need to do one more thing here. He, since we are wrapping it in the while function, it will try to shrink it, right? And after this, we can just add another check if after shrinking my window, if it still satisfies the constraint. Why would it satisfy the constraint? I should I should actually uh, I can actually uh, since it satisfies the constraint, I can actually put this I and j, store it somewhere. Let's say I have this I and j and I want to store it in such a way that I can get minimum out of it anytime I want. तो उसके लिए आई एम थिंकिंग कि लेट्स स्टोर इट इन अ we can store it in a vector and sort it later, but let's store it in a set where my initial, not a set actually, or I can store a pair of set of pair, I mean, where I have the first element as the length, so that I always get the minimum, and the second element as the starting point of that. Does that make sense? So this should be the minimum, and this should be also this should also be the minimum. Yeah, perfectly makes sense. Enough. So let's just put this in the set as j minus I plus 1 will be the length, and I would be the starting index. Perfect. Right? So so it does not matter. I can get any n number of substring that satisfies this constraint, and finally I will get them sorted in my set, and then I can pick with the minimum length out of it, or the beginning of this set would be the minimum. So I can get that very easily. Got it. Okay. I think that's it. Yeah, we are increasing our window here. If it does not satisfy, we keep increasing. The moment it satisfies, we start decreasing and insert it in our set and start decreasing our window size. And I think we are good here. We can just put a final condition over here. Why this is needed? अरे यार ये क्या? Because it may be possible कि while I try to increase this, it it came out of the bound, but still there were some elements that could have been discarded, right? For example, let's say I'm at A, B, C, D, E. I have all this in my, I have A, B, C, D in my window. I added E to my window. I think it does not. Okay, I have to be careful here because I'm doing a J++, and I think it should be one less such that when I do J++, this is still in the bounds. And it, after the next iteration, it will come out of the loop. So now it makes sense. I have these four elements, and this condition becomes false. It comes out of the loop. Sorry, this condition becomes false when I take the last element here. Got it. No, इस case में भी तो. But anyways, I think this is fine. Finally, I can just return. uh, From my set, I need the initial element. So s dot begin first will be my minimum length, and second will be my starting index. I can wrap this. So I cannot take s. I have to take st because s is already taken here. है So st dot begin, the first index, the second element will be my starting index, and this would be wrapped in a substring, starting index, and the length, which I return from here. Let's see if this is enough. Okay, something is wrong here. What happened? No matching function. Oh, sorry, st dot insert here. What? My output is nothing. What? Hmm. Okay. Okay, plus. Mm-hmm. What is wrong here? I'm increasing my window size. I'm adding the elements in the window. Uh, I am checking key. Does my window satisfies the constraint? If it does, let's see this function. I'm iterating over all the elements in S, checking the count of it. Should if it's less than what I have it in P, it returns false. Otherwise, it is fine. This function is fine. I inserted J comma. Okay, let me just see out whatever there is, whatever is there in S. I mean the set. Let's see if I'm getting anything in the set. Nothing. Let me just add a print function here, which takes in a map and prints its element and there is basically this key and value. Yeah, let's iterate over it, print it. I dot first is the key, I dot second is the value. And let me just see what's happening in S. MS, I mean. Let's also print the P and see if it's correct. NP, I mean. What happened? 927. We have print map. What's the problem? In number is this? Oh my bad. They are. I just have to call this function. Okay, let's see. Okay, P is getting okay, I got it. This s dot length is returning me a unsigned integer or something. मेरा आउटपुट क्या है? अरे यार, लेट्स दिस टाइम. Okay, I have something in my set from here. 1, 0. How come this got into the set? What? Something is wrong. How come one length and starting index is 0? J is also 0. So initially, तो P में I have what I have. J में I have only, I mean, MS में I only have one element. How come this is returning true and it's going inside? What is happening, भाई साहब? इसको हटा दे. 0, 0 आ गया. 0, 0 में कैसे ट्रू है ये? इस पॉइंट पे MS में तो सिर्फ T ही है और MP में तो TOC तीनों है. तो T में तो ट्रू हुआ ये क्योंकि T का काउंट was 1 and T का काउंट in P was also 1. तो ये फॉल्स रिटर्न नहीं किया. सेकेंड केस में ओ ओके ओके, मैंने उल्टा चेक लगाया हुआ है यहाँ पे. इट शुड बी एवरी एलिमेंट इन P. माय बैड. एवरी एलिमेंट इन P इज आल्सो प्रेजेंट इन S. क्योंकि S में कम if S has less elements then it won't do all the checks for all the characters. My bad, my bad. If I dot uh, second is less than or greater than, or let's write it this way, if S of I dot first is less than what I have in P, then I should return false. I think, yeah, that was the bug. Let's see. अब तो हो जाए यार. हाँ, I think हो गया. I think it's done. Let's remove this and check. Yes. Let's remove these debug logs and let's submit it. Cool. Uh, I hope you guys enjoyed it. If you liked this video, then I really appreciate it. If you have any feedbacks, you can leave it at the comment section. I mean feedback related to how I can make better video for you guys. Cool then. Bye bye.